Let's see what we can do here. Number 1. Does anybody have an answer for that? Yep, an answer for number 1. X equals 3. Absolutely correct. So you would need to multiply both sides by the denominator. If you multiply by the denominator of 12, you only have to do one multiplication, because if you multiply by 12, you get x all by itself in that first step. So you would have x equals 24 over the denominator of 8, and 24 is evenly divisible by 8, so x would be 3. Does anybody have an answer for the middle one, number 10, or number 2, sorry? X is 10, absolutely correct. This time, because x is in a denominator, we're going to have to do 2 multiplications, one for each denominator. Doesn't matter which one you multiply by first. So I'm going to multiply by 5 on both sides first. But again, it does not matter if you multiply by the 5 first or the x first, you get the same final answer. So I would have 6 equals 60 over x. And then I have to multiply by the denominator of x. So I would have 6x equals 60. And then you divide both sides by 6. And that's how you get that x is 10. What about number 3? What is that answer? How much? 2.5, absolutely correct. So I'm going to multiply both sides by 12 by this denominator. That won't get x all alone, but because I have no x's on the other side, it's going to be close enough to being all alone that I can simplify the right-hand side. So I would have x plus 2 equals 36 over 8. Because 36 and 8 have no variables with them, I can pop that right into my calculator. And 36 divided by 8 is what? What is 36 divided by 8? 4.5. So then I'm going to have to subtract 2 from both sides because I have x plus 2 equals 4.5. We minus 2 on either side, and that's how we get that x is 2.5. For the last 2 problems, we have to set up the proportions ourselves. So on number 4, we've got 2 similar triangles. We need to match up the corresponding sides between the left-hand triangle and the right-hand triangle so we can make fractions. What would be the corresponding side on the right-hand triangle for x? Which one? So on the other triangle. So I have x on the left-hand triangle. On the right-hand triangle, that would correspond to this right here. This short side is going to match up with the other short side. Or the other thing that I can look at that would be better is that there's this angle marking here, this arc mark, and this here also has an angle marking. The other 2 sides have no angle markings on them. So x and 3 have to make a fraction together. Does not matter which one you put on top, but if you put the x on top, you'll have less steps that you need to go through to solve this. And then we have to match up the other 2 corresponding sides. Guys, phones have got to be put away. Put them away, leave them away for the rest of the class period, please. Which number, the 4 or the 6, would have to go in my numerator? The 4. Same triangle as the x, and x is in my first numerator. So 4 over 6. To finish solving this for x, we're going to multiply by our denominator of 3. You can multiply by the denominator of 6. It's just going to give you an extra step that you will need to go through to finish solving, but it is not incorrect. So x equals 12 over 6, and 12 divided by 6 is what? 2. Did you do it differently but get the same answer? You should be good with your setup then, even though it's different. It's just another way to do it. You have to make sure that you get your numerators and denominators matched up correctly. But yeah, your way of doing it works. Number 5, very last problem. Does anybody have an answer for this one? 2.6 repeating. Yes. Okay, so on this one, There's a couple ways you could go about setting it up, but my personal opinion is that the easiest way is to match up and stay on the same side. So I would need to make a fraction with the 2 and the 3. Doesn't matter which one you put on top, so I'm going to put left on top of right. And then I would move to the other side of the triangle, and I would match up these two segments, the x and the 4. The reason that I'm allowed to set it up like this is because of these parallel markings right in here. If I did not have those parallel markings, but I just had that the two triangles were similar, I would have to add the sides together to get my big triangle. But here, because I've got the parallel lines and I have the segments that are being split by those parallel lines, I can make fractions by staying on one side of the triangle and then the other side. Like 3 on top of 2 and 4 on top of x, or 2 on top of x and 3 on top of 4. X under the 2, you could do that. You could do 2 over x and then 3 over 4. That would be another correct way to set that up. That way of setting it up is very similar to the proportions that we saw on the warm-up yesterday when we were asked to match up those segments that made fractions together that are equal. So either one of those setups will work. I'm going to solve this one because when my x is in the numerator, I usually have less work to do. So I would have the 4 times 2, that gives me 8 over 3 equals x. That is a fully reduced fraction there. If I wanted to leave my answer in fraction form, 8 over 3 would work. Or in its decimal form, 2.6 repeating. Again, if you set it up this way, you would get the exact same final answer. It's probably just going to take you one more step to get there, but that is perfectly fine. It is an okay way to set that up. Yes? So you had 5. So the only thing here, you added those 2 to get the 5, which is correct. But here, you multiplied. If you had x plus 4 and you set it up that way, you would get this same answer. And that is also a perfectly okay way to set this up. Yes. All right, you guys are going to be turning in your warm-ups, so please go ahead and either put them in the tray or you can leave them on your desk and turn them in at the end of class. That's up to you. But the rest of our class time together, I'm going to spend answering any questions you guys have off of the test review. So after you turn in your warm-ups, please grab your test reviews. You had a chance in class yesterday to work on those. I'm hoping you ran into some things yesterday and last evening that you have questions about that you would like me to go over. What problems from the review would you guys like me to go through? Any of the problem numbers? Number 2, sounds good. Let's start there. For each set of triangle vertices, find the coordinates of the vertices of the image after a dilation of the triangle by the given scale factor. Remember, scale factor, they often will use the letter K to denote that. So right here, this is my scale factor. The way we do these is we take both the x part and the y part of the ordered pair, and we are going to times it by that scale factor. So I'm going to multiply each of these by 0.25. So when I multiply 4 by 0.25, what do I get? 4 times 0.25. Yes. Yep, very bottom paper over there. 1. And then we do 8 times 0.25, and that gives us 2. So our first dilated ordered pair is 1, 2. Because I already know that 8 times 0.25 is 2, that means the second ordered pair would have to be what? 2, 2. Third ordered pair, we do 4 times 0.25, which we've already done. What is 4 times 0.25? 1. And then 2 times 0.25? 0.5. You could write that as the fraction 1/2 if you wanted to, but you can also write it in its decimal form. Either one of those is fine. Similar situation over here on, I don't know why those are C and D, that should be A and B. So this 1.5 right here, this is our scale factor. So we're going to multiply each of these ordered pairs by 1.5. This first ordered pair almost seems like a trick. What happens when I multiply anything by 0? 0. So my first ordered pair stays 0, 0. What is negative 2 times 1.5? Negative 3. And then 0 stays 0. What is negative 1 times 1.5? Negative 1.5. And then 2 times 1.5 is 3. What else would you guys like me to go over from the review? Number 4 and DeBoer? 15? All right, so let's do 4 next and then 15, and then we'll take more questions. Number 4 has several parts to it. A, B, C, D, E, F. We're supposed to determine whether or not the triangles are similar. If we decide that they are similar, then we need to write the similarity statement. So triangle something similar to triangle something else. And the reason. Things that we can use as reasons would be angle-angle similarity, side-side-side similarity, and side-angle-side similarity. If they're not similar, then we have to explain why. All right, so part A. Should I be trying to see if they're similar by angle, angle, side, 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 or side, angle, side? Side, side, side. We have 3 sides on one triangle, and we have 3 sides on the other triangle. So let's try for side, side, side. When we look at side, 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 we have to make sure to match up the smallest sides together. So the smallest side here is 11. The smallest side on the other triangle is 8. So I have to make a fraction out of those. It does not matter which one I put on top, which one I put on bottom, as long as I stay consistent with my next fraction. So I'm going to do 11 over 8 just because it's left-hand triangle over right-hand triangle. And then we're going to match up the biggest sides. So I'm going to match up 13 and 10. Left-hand triangle over right-hand triangle. And then our 2 leftover sides, the medium-sized sides, the 12 and the 9 have to match up. So 12 over 9. I want to know whether or not these come out to be the same. What is 11 divided by 8? 1.375. The other 2 have to come out to be that exact same decimal. Not one number more, not one number less, and no numbers different. If any of them are different, or it's less or more, they are not similar. What is 13 divided by 10? 1.3. Is that identical to what we just got? I don't even need to keep going. That's enough right there for me to say not similar. If we say not similar, we have to give a reason. My reason would be that the corresponding sides are not proportional. Excuse me. Part B, even if they didn't have it marked for me, I see we've got these vertical angles here. So I'm going to try to go after a similarity that uses at least one angle. Should we try for angle, angle, or side, angle, side? Side, angle, side. I notice on the top triangle, both of these sides are 12. And on the bottom triangle, both of those sides are 8. So no matter which side I match this first 12 up with, the other part of the fraction is going to be an 8. So I have 12 over 8 equals 12 over 8. Is that true? Does 12 over 8 equal itself? Yeah. I don't even need to take this one into its decimal form. I could say 1.5 is equal to 1.5, and I could check it that way, but either way it checks out. So yes, the triangles are similar. Now we need to write our similarity statement. First triangle doesn't matter how we name it, so let's call that DBF. Similar to triangle. Because these two sides are the same, that means these base angles would be congruent to each other. And the same thing is true on that bottom triangle. We have isosceles triangles here, so these base angles are going to be congruent. So if I have to make sure to match up my congruent angles, D is the same size as A or C. So I could match angle D up with either A or C. Which do you want to do? Because it doesn't matter. We could do A, B, C. Or, because they are both isosceles triangles, we could do DBF is similar to CBA. Both of those would be correct. What is our reason for saying they're similar? Side, angle, side. Similarity. Don't forget the squiggle at the end. All right, so there's A and B. Let's go look at C and D next. For part C, which reason should I try? Angle, angle, side, 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 or side, angle, side? Let's try side, side, side again. So smallest to smallest. So I have to match up the 3 and the 4. To keep it simple, I'm going to just do left-hand triangle over right-hand triangle. Then I match up my largest sides, 7.5 and 10. And then I match up my leftovers, my medium-sized sides, so 6 and 8. What is 3/4 as a decimal? 0.75. What about 7.5 over 10? 0.75 again. What about 6 over 8? 0.75. These all came out to be the same. So yes, the triangles are similar. We have to give our similarity statement. Can somebody name one of those triangles for me? We could do YXW or XYW. XYW is the first one that I heard, so I'm going to go with that one. Triangle XYW is similar to, and now I've got to make sure to match up corresponding parts. So the first 2 letters here are XY. That side I have a little purple square around. That one corresponded with BC down here. Or sorry, no, I circled XW. We did XY first. My apologies. First 2 letters are XY. So that would correspond here to DC. Should I put the D first or the C first? C should go first. So C, D, and then B. I can keep checking this if I need to. So the second two letters, the Y and the W, that's going on this side. That corresponds to this. So that's another way that I see that I need D in the middle and then B at the end. So triangle XYW is similar, I wrote that in the wrong spot, to triangle CDB. I don't know why I wrote it up here. And what would our reason for that similarity be? Side, side, side similarity. Part D. I see some congruence marks here. Despite my eyes trying to deceive me, it says that KL is the same size as XW. It says that NL is the same size as XY. Do I have any information about any of the rest of the triangle? Nope, I don't know about any other angles. I don't know about any other sides. Is side, side enough to say these triangles are similar? No. So here I would say not similar, and my reason for that is not enough information. Side, side is not a way to show similarity. Last two, E and F. Oh, sorry, let me go back. I didn't realize people were still writing. All right. Last two, E and F. So on E, there's no markings on any of the sides. I don't have any numbers. I don't have any congruence marks. So I'm going to have to try for which one? Side, 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 angle, side, or angle, angle. I'm going to have to try for angle, angle. If I have no information, no congruence marks, no numbers on those sides, I'm going to have to look for angle, angle here. Looking right here in the center of the bow tie, what can I mark? Vertical angles. And then there's something else that I notice on both RS and BC. I see these little arrow shapes. What does that mean? Parallel. When I see a bow tie and parallel, what letter should I draw? A Z. We're going to go over the parallel line, across a transversal, and then over the other parallel line. That Z shape helps me find my alternate interior angles. Alternate interior angles are congruent if the lines are parallel. And here we were told the lines are parallel. I could have drawn my Z the other way, just so that we don't get any confusion. I could have done it like this, and then I would have had S and B as my congruent angles. So yes, the triangles are similar. Let's call the first one triangle RSA. Which angle corresponds to angle R? C. Which angle corresponds to S? B. And then angles A and angle A, those are my vertical angles. So triangle RSA is similar to triangle CBA by angle, angle, similarity. And then the last one, part F. It says that angle RTU and RUT are congruent. And then angle Q and angle S are also congruent. Are these two triangles similar? Yes, I have a pair of corresponding angles here. And over here, I have another pair of corresponding angles that are congruent. So these triangles are congruent using which reason? Using angle, angle. All right, so let's name the little triangle first. Let's call that RTU. Triangle RTU is similar to triangle RQS. Or because those four angles are all congruent, we could say that RTU is similar to RSQ. Either one of those would work by angle-angle similarity. All right, number 15 was the next one I was asked for, and then I'll take any other requests you guys have. So all the way to the very end of the packet. So questions like this usually don't show up like this on the test, but the ideas that come from writing down these statements, those usually are used on the test. So this is to kind of get us thinking, and I asked for 10 because usually we can spit out a couple of them right away. And pushing you to give 10 means that you have to get your mind thinking outside of the box or pushing it just a little bit. So first thing I notice is it says that K, M, and P are all midpoints. Head up for me, dear. If those are all midpoints, then that means we call segment KM, segment KP, and segment MP what? What do those all get called? Mid-segments, because they're joining two midpoints together. So KM, KP, and MP are all mid-segments. We learned two different properties about mid-segments and the side that they do not intersect. So let's look at these two, like KM and JN. KM does not intersect JN, so that would be my third side. What's one of the properties we learned about a mid-segment and that third side, the side it doesn't intersect? Yes, the mid-segment times 2. So KM times 2 would be equal to what? JN. Or another way of stating that exact same thing, and I can get another equation or statement out of this, is I could say KM is half of JN. How big is JN? 14. How did you get that? How did you get 14? They're congruent, so that's another thing I can write down. Because P is a midpoint, JP is congruent to PN. So that means this one over here would have to be 7. So that's not the only way that you got 14. That's how you knew the other segment was 14 or was 7. How did you get the 14 from that? You add them. So JP plus PN gives me JN. I've got 4 statements right here, and we're still just looking at the same 2 segments here. I could even say that JN is 14. That's another true statement. How big's KM? 7. I've got 6 statements, and I'm still just looking at the same parts of this triangle. All right, let's branch out now. What is another true statement we could make here? Let's look at something other than J, N, and KM. PM is equal to what? It's equal to 2? 10. PM is equal to 10. If PM is 10, how big is JL? What's something else true that I could say about this picture? LM is equal to 1/2 of LN. Absolutely. There's a couple more statements we can make. First period asked me about this exact same problem. We came up with 10 almost entirely different statements. So I will be posting all of these, and I have that video that's going to be posted later, but feel free to look at this question in a couple other classes just to see some of the other statements we can come up with. I could give us another one for free here. We didn't just learn that the mid-segment was half of the side it doesn't intersect. One of the other things we learned is that that mid-segment, so I'm going to say PM here, is parallel to the side that it does not intersect. So PM would be parallel to JL. So that's another statement I could make here. Yes. KM, thank you. That would be me not looking at the letter close enough. KM. Thank you for catching that mistake. Yeah, because KN is not even a segment that's up there. What else do you guys want to see? Yes. 14 sounds good. Number 14. Okay. So there are some little markings that should have been on the picture. This right here. I apologize. So one of the ways that you can set this problem up, because those lines are parallel, is I can look at one side over here, and I can make a fraction out of that. 7x minus 9 equals 4x plus 12. And that would be equal to, and then I come over to the other transversal, and I look at those two pieces, and I make a fraction out of that. So 17 over 17. What is 17 divided by 17? It's 1. So 7x minus 9 equals 4x plus 12, or sorry, over 4x plus 12 equals 1. To get rid of fractions, we multiply by the denominator. So 4x plus 12, we multiply on both sides. And that would give me 7x minus 9 equals, and I distribute 4x plus 12. Get the x's together. So subtract 4x from both sides. That would give me 3x minus 9 equals 12. Then I would add 9 to both sides. What is 12 plus 9? 21. So 3x equals 21. And then I divide both sides by 3. And I get that x is what? X is 7. So I said this was one way to set it up. There's another way that we could set this up. If you had noticed at the very beginning, which I'm sure a lot of you did, that the 17 and 17 are the same, so that means these two are congruent segments. If on one transversal the segments are congruent, that means the segments on the other transversal are also congruent. So because 17 equals 17, I can jump right to this step where I would say 7x minus 9 equals 4x plus 12, which I did eventually get to in the other way we set this up. But I can take that shortcut when I have congruent segments. If 17 was on top but 17 wasn't underneath, then I would have to set it up the way I did originally. If they're not congruent, then I cannot take that shortcut. All right, I got 3 more minutes, which is probably enough time for one short problem. Does anybody else have something they would like to see? Yeah. Yes, you could absolutely. You could also set that up as 7x minus 9 over 17 equals 4x plus 12 over 17. That would come out exactly the same as well. Yes, you could set it up like that. Now, this is another way of setting it up that will work every time, even when you don't have congruent segments. 17 over 12, 4x plus, or 17 minus 9 over 7x minus 9 over 17, 4x plus 12 over 17. Even if those weren't both 17s, this would be an okay way to set it up every single time. All right. That probably takes us to the very end. Don't forget, you're going to be turning in your test reviews tomorrow. Answer key for my test review, or my answer key for this test review, will be going up next period. So you guys will have access to that. You need to go to Canvas. You need to go to today's module and click on that page. And when you scroll to the very, very bottom of that page, that is where you will find the answer key. I'm posting videos from every single one of my geometry classes today. So there's going to be 5 videos up over the review. If you had a question about one that we did not go over in class, check out the videos from the other classes so that you can see what questions they went over. Watch them in fast forward though, like put it ×2 so that it gets to the questions that you're interested in faster. You can always slow it down.